Well, good morning everyone in Adelaide and good morning everyone online. In my brief presentation today, I'd like to provide something of a steel industry overview and the broader economic considerations that are critical for a successful transition to zero carbon steelmaking. So while I'm very interested in the technical detail of the various novel iron making and steelmaking technologies that are under development, I'll concentrate mostly on the policy and economic aspects of commercialisation of these initiatives. Briefly, the Australian Steel Institute, who I'm representing today, is a member-based organisation that covers the complete supply chain from steel producers such as BlueScope, Liberty, InfraBuild, through to distributors, processors, design, structural engineers, heavy engineering shops, fabricators, manufacturers, roll formers and installers. This very broad representation means that we are uniquely positioned to facilitate member collaboration on matters of common interest or concern, and certainly decarbonisation is one of those that falls under that category. Under normal circumstances, this is very difficult because the provisions of our anti-competition laws mean that competitors can't really come together and pool resources, but that's what we're in a position to do. I'll probably state the obvious here, but steel's a very important material. Steel, due to its fundamental physical properties, is a very versatile material, and it is used in, or fundamental to, most aspects of our modern society and the economy that supports it. This applies both to long-standing traditional industries such as building and construction, and also to more recent industries such as renewable energy generation. Think of wind towers, turbines, frames and support structures for solar panels, and even platforms for wave power generation. In recent years, despite extensive industry restructuring and some very high-profile business transformations over the last decade, domestic steel production and the associated downstream industries remain a significant contributor to the Australian economy. The steel industry is also noteworthy in terms of having a high proportion of jobs and businesses located in regional areas or non-capital cities, where unemployment is typically higher than the national average. The industry is technically complex and requires a highly skilled workforce to support it, which in turn encourages the ongoing presence of high-quality tertiary education institutions in regional areas, all of which are good things. I'd like to switch briefly now to describe the global steel industry using some statistics and charts provided by the World Steel Association, of which we're a member. Looking firstly at the chart on the left-hand side, you can see that global steel production, the line that's zigzagging steadily up there, has now passed 1.8 billion tonnes of annual production. And the forecast is for continued growth in the years to come, largely driven by continued expansion of the Chinese steel industry. In the little table overlaid on this chart, you may be able to note that whilst the annual growth rate is slowing to around 2 to 3%, the annual incremental production increases are still very significant in tonnage terms, because we're talking about small amounts of a very large base. Looking now at the chart on the right-hand side, we see here the indexed annual consumption of energy per tonne of crude steel. In this case, the energy consumption can be used as a proxy for CO2 generation. The good news is that the rate of CO2 generation per tonne has fallen very significantly since the 1960s, and there was a lot of, I guess, modernisation, adaptation, new technology that supported that. But since the 1960s, the bad news is that the rate of improvement has slowed or even plateaued from around 2005 onwards. And the final point on this slide to mention is the blue text box on the bottom right-hand side, which concludes that in 2017, approximately 1.8 tonnes of CO2 was emitted per tonne of steel produced. That's a world average. And I guess somewhat of an estimate. Also, a lot on this slide to unpack, so I'll just take a few minutes to explain it. This data all comes also courtesy of the World Steel Association, and it's based on self-reporting done by member companies. So each of the little bars that you can probably just make out is an individual steel company who's provided this data on a confidential basis through to World Steel. So the first point here is that there are two principal processes in use for large-scale carbon steel production. The integrated process accounts for approximately 70% of production, whilst the mini-mill or electric arc process accounts for the remaining 30% of production. The integrated process uses mostly virgin raw materials, coal and iron ore to make iron in a blast furnace, then oxygen-based steelmaking. The mini-mill process uses mostly scrap in an electric arc furnace or EAF to make steel. The reliance on coal in the integrated process means that it has significantly higher emissions of about 1.85 tonnes of CO2 per tonne of crude steel, and these emissions are largely in the Scope 1 category, although there are typically some credits from use of byproduct gases to generate electricity. The mini-mill process emissions are much lower at about 0.4 tonnes of CO2 per tonne of crude steel, and these emissions are largely in the Scope 2 category associated with externally sourced electricity. The final point of this slide is the significant performance gap between the top performers and the overall population of steel producers in each category. So the left-hand side shows the top performers, the right-hand side in each grouping shows the overall population. This indicates that there are opportunities for continued incremental reduction in CO2 emission with existing technology. Closing this gap is a key focus area for World Steel Association and its members, and the resultant improvements will continue to incrementally drive down CO2 process emission intensity in the short to medium term. Turning now very briefly to some of the breakthrough initiatives being developed around the world, we can see that there are a wide range of options being pursued. These include carbon capture and storage, partial replacement of coke in the blast furnace with hydrogen as a reductant, through to adoption of completely hydrogen-based reduction technologies for iron making. The impact on CO2 emissions ranges from significant reductions through to complete elimination. Importantly, the mix of initiatives contains both bolt-on options that can be added to existing processes for relatively low capital costs, for example, the Course 50 programs is a good example, through to completely new process flow sheets that require construction of greenfield steelmaking facilities, such as the hybrid initiative. As is the case for all new technology development, successful commercialisation of some or all of these processes will require extensive testing, solutions for essentially new-to-the-world problems, and progressive scale-up to the size required for cost-effective industrial operation. Perhaps most significantly, the timescale for this development is currently projected to be multi-decade. Switching back to the Australian context, we have 4 domestic steel producers, all making a specific range of end products for different applications. For example, BlueScope supplies roofing and cladding materials such as ColourBond, InfraBuild produces reinforcing bar for construction applications, Liberty, John's business, makes, amongst other things, railway products and structural beams, whilst Molycop makes grinding media for the mining industry. Of the national annual production of approximately 5.25 million tonnes, roughly 3/4 is made using the integrated process to convert iron ore and coal, with the balance made using the mini-mill process to melt scrap. I won't comment on the individual plans and initiatives of our producer members to reduce CO2 emissions, other than to observe that all are actively engaged in the need for CO2 emission reduction and working on a range of incremental measures. So, to summarise, the transition to zero carbon emission steel production is expected to take multiple decades before fully commercial processes are proven at industrial scale. This transition will require very significant capital investment on the part of producers, set against a background of significant technical risk and complex technology development challenges. This task is well beyond individual steel producers to achieve when you consider that total Australian steel production accounts for less than 0.3% of global steel production. Therefore, the Australian Steel Institute believes that the best chance of success lies in coordination of local producers to pool resources for the transition to breakthrough zero carbon technologies. Although Australian steel is relatively insignificant in global terms, it does constitute roughly 8% of national emissions, concentrated at a small number of sites and businesses. So it's very worthy of prioritisation because of the impact we can make just in one industry. And finally, my final comments, I guess, underpinning this necessary transition is the need for policy settings that provide confidence for industry to make long-term investments and commitments. Included amongst the policy settings is the need for a level playing field, whereby all the steel used in Australia, regardless of where it is sourced, is subject to the same sustainability criteria, particularly as regards CO2 emission intensity. Thank you.